here I am taking a body. Actually, this body is a point. You can say it is a point. Where body is there, in the body, number of stresses are acting. Number of stresses are acting. I am taking only one point in the member. I am taking only one point in that member. In that point, there are number of stresses are acting. So this is that point. This is actually here I have shown like a body, but this is a point. At that point, number of stresses are acting. One is sigma p, sigma x along x direction. One action is there, another reaction will be there. So sigma x is acting along right and left. Then sigma y is acting in vertical direction. Apart from that, yes, shear stress is acting around the member. Shear stress is acting around the member. So these are all the three stresses. These are all the three stresses. Now a small portion is cut. A small portion is cut. Now what is a load? Let us not take stress. If there is a load, if there is a load along x direction, my intention is to calculate, to resolve the force into this direction. This is theta. This is vertical plane. This is vertical plane. This is a body. This is a body. Here system of forces are acting. My intention is I want to resolve the forces along this direction. There is a plane now. This is a plane. Along the plane is at an angle of theta from the vertical. At an angle of theta from the vertical. My interest is to resolve the forces along this plane. Along this plane. One is perpendicular to the plane, another one is along the plane. So I want to convert all the forces into along the plane and perpendicular to the plane, right? If it is perpendicular to the plane, this may be that this is a direction. This is a direction. This direction. Similarly, this parallel to the plane, this will be the direction. This will be the direction. Let me draw a little bigger. So this is perpendicular to the plane. What is a plane? This is a plane. This is a plane perpendicular to the plane. This direction. This direction. This is parallel to the plane. This direction. Right? If this is P, if this is P, and this is theta, this is theta. If this is theta means this also will be theta. And what will be this value? This is P into cos theta. P into cos theta. And this will be P into sin theta. P into sin theta. The direction will be this direction. Here this direction is, the load is acting along this direction. If we resolve this, here the direction will be along this direction. Here this will be the direction. This is 90 degree. This is 90 degree. So if you draw, if you take sin theta, opposite side by hypotenuse, that is opposite side by hypotenuse. We want to find this distance. So P into cos theta, P into sin theta. So similarly cos theta you can take. Right. Now one force is acting along this direction, vertical direction. Now one force is acting along vertical direction. I want to resolve this along this direction as well as along this direction. Along this direction. This direction means it will be like this. This direction means it will be like this. That is, let us take this is some tau. Let us take this is some. This is also some load. If you want to resolve this will be 90 degree. This is 90 degree. Now this is theta. This is theta. Now this is what will be this? This is tau into cos theta. Tau into cos theta. This is tau into sin theta. Tau into sin theta. Right. Here in this sketch, this force is horizontal. Sigma x is horizontal, and this tau is horizontal. Tau is horizontal. So if you want to convert this into this direction, you can refer this figure. You can refer this figure, because I have taken some load. I have resolved into this direction and this direction. It's a horizontal force. So here sigma x is horizontal force. This tau is horizontal force. We can resolve using this diagram. Similarly, this tau is vertical. This tau is vertical. The sigma y is also vertical. If you want to resolve this along this direction, you can refer this diagram. You can refer this diagram, right? Now, if this is vertical direction, if this is a direction, means here if you resolve, this will be the direction. Here, this will be the direction. This will be the direction. Now, I am going to derive this equation. So first I am going to calculate sigma n. Sigma n. What is sigma n? Sigma n is, this is a plane. I want to calculate the load or stress perpendicular to the plane. Perpendicular to the plane. Here we given sigma x, tau, sigma y. All are stresses. All are stresses. Not load, stresses. Now, how to convert the load? We have explained here. We have explained here. Now, sigma n. I want to find, I want to resolve all the stresses along this direction. Along this direction. So sigma n is equal to, this is sigma x. Sigma x is a stress. Sigma x is a stress. So first you convert the stress into load. Load means you have to multiply with the area. This load is acting in CD. 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 Similarly, sigma n also I have to convert into that. I will like okay. I want to find sigma n. Let it be. I will explain later. Now sigma x into cross section area. Cross section area is CD into perpendicular distance you have to put. CD into perpendicular distance you have to put. Perpendicular distance is not given. You take it as 1. Take it as 1. CD into perpendicular distance. That is a cross section area. That is a cross section area. That is not known. You take it as 1. This is what the sigma x is converted into load. Now I want to convert into this direction. I want to convert it to this direction. This is a horizontal force. Horizontal force. When there is a horizontal force, if you want to resolve into this direction, what you have to do? You have to multiply with cos theta. So cos theta. Now this force become converted into this direction. Resolve into this direction. This is cos theta plus now, and another one horizontal force is there now. This also horizontal. This also horizontal. I convert this also into this direction. If it is horizontal, I want to convert in this direction. What you have to do? I have to put cos theta. I got to put cos theta. Here the stress you have to, first you have to convert the stress into load. Tau is stress into what is the area? CD. CE into 1. Because perpendicular distance we don't know, you put 1. So this is load. If you want to convert this into this direction, what you have to do? You have to put cos theta. You have to put cos theta. Plus, now you take sigma y. You take sigma y. Sigma y is vertical. The vertical I want to resolve along this direction. Along this direction. If I want to convert this into this direction, what you have to do? I have to refer this diagram. Vertical into this direction. And so not this direction. I have to put sin theta. I have to put sin theta. So tau multiply, sorry, not tau. This is sigma y. Sigma y into stress. Into this is stress. You will convert it to area. Multiply with area to convert into load. EC. Sigma y is acting here. So this is EC or CE. CE into 1. Perpendicular distance is 1 into sin theta. Sin theta plus another one tau. You consider this is horizontal now, this vertical now, this tau vertical. Now you convert this also into this directional force. For this you refer this, that is tau into what is the area? Area is equal to CD into 1. The shear stress is acting here. The area will be CD into 1 into sin theta. Now this is a force, because stress into area we converted, so force. So sigma n also you have to convert it into force. You have to convert it into force. This is stress. Sigma n into area. What is area? It is acting in CD. So CD. What is the perpendicular distance? 1. So here all the equation, the perpendicular distance is taken as 1. So you can cancel, right? So now if you take sigma n, what will come? Sigma x and sigma x into CD by, and this is CD. This is not CD. This is, sorry, this is this distance. This is DE. So you will get CD by D, DE into cos theta plus tau into C, CE divided by D, DE into cos theta plus sigma y into CE by D into sin theta plus tau into CD by what D, DE into sin theta, right? Now what is CD by D? What is CD by D? What is CD by DE? CD by DE. This is theta. This is theta. This is 90 degree. This is CD. This is DE. Cos theta. Cos theta is equal to adjacent side by hypotenuse. So this will be cos theta. This will be cos theta. What is CE by DE? What is C? This is CE. This is DE. Opposite side by hypotenuse. That is, this is sin theta. Similarly, CE by this is sin theta. This is cos theta. Now, then trigonometry, using trigonometry, if you manipulate it, you will get an equation like this. You will get a equation like this. Sigma n is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau into sin 2 theta. You will get an equation like this. You will get a equation like this. You will get a equation like this, right? Normal stress sigma n is equal to sigma x plus sigma y by 2 plus sigma y minus sigma x minus sigma y by 2 into cos theta plus tau into sin 2 theta. This is a equation you will get. Now, one more equation. We have resolved all the forces along this direction, normal direction. Now we are going to resolve along this direction, sigma t, along this direction. So sigma t into what is the area? The same d, d into 1. So this is force acting along this direction. You convert all the stresses along this direction. So now you take sigma x into CD into 1. I want along this direction. If I want to convert it along this direction, you have to put sin theta. You have to put sin theta. This is acting downward direction. Now you take the tau. It is acting vertical direction. This tau. It is acting in the horizontal direction. This is acting in the horizontal direction. It is acting in the horizontal direction. So if you resolve along this direction, the same thing. Plus tau into area CE into 1 into sin theta. Now you take sigma y. Sigma y is acting along the vertical direction. I want to resolve along this direction. Vertical means here it is vertical. I want along this direction. Here see here the force is acting downward direction. Here it is acting in the upward direction. So opposite means you put minus what? Sigma y into area CE into 1 into cos theta. If you want to resolve vertical into this direction, you have to put cos theta minus tau into CD into 1 into cos theta. Now you divide by D. D is in the left side. You divide the equation by D, 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 D. So CD by D, you know, cos theta. C by D, sin theta. C by D, sin theta. CD by D, cos theta. You put. Then you manipulate. Finally, you will get sigma t is equal to sigma x minus sigma y by 2 sin 2 theta minus tau into cos 2 theta. This is a equation you will get. So these equations are used to what? When a point is subjected to system of stresses If you want to calculate the stress along a plane and perpendicular, you can take any plane. You can take a plane here, 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 wherever it may be. You take plane anywhere. You take plane anywhere. If you put the value of theta, just if you substitute the value of theta, this will give normal stress. This will give tangential stress. So these equations are used to find what the sigma n and sigma t at any plane, at any plane, by just substituting the theta value. Now see, this is the system of forces acting on the member. Our interest is to find the sigma n and sigma t. What is sigma n? I have taken a plane. I have taken a plane which is at an angle of theta from the vertical. It is at an angle of theta from the vertical, this plane. So normal to the plane, sigma n, parallel to the plane, sigma t. These two we need to calculate. How to calculate this? We have discussed in the last class. Now, what is sigma n? Sigma n is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos 2 theta plus tau sine 2 theta. This is the equation. To find the value of sigma t is equal to sigma x minus sigma y by 2 sine 2 theta minus tau into cos 2 theta. So this is the expression. So what is the use of this expression? What is the use of this expression? This expression is used to calculate the sigma n at this plane. At this plane, by substituting the value of theta, different value of theta, you can find sigma n at any plane. If you put 2 theta is equal to 0, that will give stress at sigma n at this plane. Sigma n at this plane. If you put 10 degree, it will give sigma n at this plane. Similarly, 45 degree, at any degree you can substitute and you can find the value of sigma n. Similarly, sigma t. So this is a generalized equation. This is a generalized equation. This will give sigma n, that is normal stress, sigma t, that is tangential stress, at any plane. At any plane. So in this equation, if sigma y is not known, not given, you can substitute sigma y is equal to 0. Sigma y is equal to 0. Then sigma y is equal to 0. If point is consisting of sigma x and tau, there is no sigma y, then you can put sigma y is equal to 0. For example, tau is not there. Tau is not there. Then you put tau is equal to 0. Tau is, so this is for two perpendicular forces as well as a shear force. If something is not given, you can put that value is 0 and you can get the data. Similarly for sigma t, right? This is generalized equation. For any angle, for any system of forces, you can use this equation. If one is there, you put that 0, right? Okay. So now, but our interest is to find the maximum sigma n and maximum sigma 2. If you substitute the value of theta, different theta value, you will get different n value. But at one position, it will be maximum. Sigma n will be maximum. Am I right? The sigma n value will be maximum at one point. Similarly, sigma t will be maximum at one point. So according to theory, it is says that sigma n is maximum when sigma t is equal to 0. Generally, what we will do is we differentiate sigma n by with respect to theta and equal to 0. You will find the value of theta. That is one procedure. But already it is there is a theory that when sigma t is equal to 0, when tangential stress is equal to 0, or we can say it is when shear stress is equal to 0, sigma n is maximum. Sigma n is maximum. So you equate sigma t is equal to 0 and find the value of theta and substitute the value of theta here, and you can find the value of maximum sigma n. maximum sigma n, right? So now what we are going to do is we are equating this to 0. You substitute sigma t is equal to 0. If you substitute sigma c t is equal to 0, 0 is equal to sigma x minus sigma y by 2 sine 2 theta minus tau into cos 2 theta. Now you take this right side. Take this right side. So minus become plus. The equation will be like this. Now sine theta by cos theta. Now sine theta by cos theta. Not the theta 2 theta. Sine 2 theta by cos 2 theta is equal to what it is, 2 tau divided by sigma x minus sigma y. This is equal to tan 2 theta. Tan 2 theta. Now you find the value of theta. You find the value of theta here and find the value of theta here and substitute in this equation. Substitute in this equation. If you substitute, you will get the equation that is maximum sigma n. Maximum sigma n. That is known as maximum principal stress. That is known as maximum principal stress. Maximum principal stress. Right? What is that value? That is equal to sigma. Let us take sigma 1. Sigma 1 is equal to sigma x plus sigma y by 2 plus root of sigma x minus sigma y by 2 the whole square plus tau square. This is not theta independent. It's not a function of theta because this is a maximum value. When theta is equal to, when tan theta is equal to this value. This value. So for theta, some value for this theta, that sigma n is maximum. Sigma n is maximum. That value is this value. Similarly, you can find the value of minimum value also you can find. Sigma 2. Sigma 2. For sigma 2, the same equation, instead of plus, you put minus. You put minus. So, sigma 1 comma sigma 1 comma 2 is equal to sigma x plus sigma y by 2 plus or minus root of sigma x minus sigma y by 2 the whole square plus tau square. This is the equation. If you want maximum, you put plus. If you want minimum, you put minus. Right? So when it will be minimum, when theta is equal to theta plus 90. Theta plus 90. When theta plus 90, the value will be minimum. The value will be minimum. You understand? This equation gives the what? Sigma n at any theta. This equation will give sigma n at any theta. But now we calculated the maximum value of sigma n and minimum value of sigma n. The maximum value of sigma n is sigma 1. That is maximum principal stress. The minimum value of sigma n is equal to minimum principal stress. That is sigma 2. That you have to put minus. So when at what angle sigma 1 is maximum? At theta. Theta can be calculated using this equation. Using this equation. When sigma 2 that is sigma n is minimum when theta plus 90. Theta plus 90. Similarly, you can find the maximum shear stress also. The equation is root of sigma x minus sigma y by 2 the whole square plus tau square. This is the equation. When it will be maximum? This is theta plus 45 degree. Theta plus 45 degree. Okay. So now this is a generalized equation. This can be used to calculate sigma n at any angle. This is generalized equation. This can be used to calculate sigma t at any angle. Now from sigma n we calculated sigma 1 and sigma 2. That is maximum sigma n and minimum sigma n. That is maximum principal stress and minimum principal stress. By using this equation, sigma 1 is when sigma 1 is maximum when it is at theta. How to calculate theta? You can use this equation. When it is minimum, when theta, angle is theta plus 90. Minimum is sigma 2, that is minus, minus if you put minus. When tau is maximum? When theta plus 45. Theta plus 45. What is the value? Sigma x minus sigma y by 2 the whole square plus tau square. This is the equation. Now you come to the slide. This is a derivation. It's a very big derivation. Very big derivation. I have given the extract. I have given the extract. Extract is, the concept is given. Then trigonometry, we are going to solve one problem. We are going to solve one problem. This is system of forces. System of forces. System of forces are acting. See, this is a point. This is a point. In that point, there is a sigma x. That is, sigma x is 180 Newton per millimeter square. Sigma y is 120 Newton per millimeter square. And shear stress is 80 Newton per millimeter square. 80 Newton per millimeter square. Now, our objective is to find magnitude and direction of principal stresses. What is meant by principal stresses? Minimum principal stress, maximum principal stress. There are two principal stresses, maximum principal stresses and minimum principal stresses. You need to find magnitude and direction. Magnitude and direction. Direction means theta. Magnitude is the value you have to find. Then magnitude and direction of maximum shear stress. Magnitude and direction of maximum shear stress. And indicate all above stresses in a plane. Indicate all above stresses in a plane. Now we need to calculate sigma 1 and sigma 2. Sigma 1 and sigma 2. First you can calculate theta also. Tan 2 theta. Tan 2 theta is equal to 2 tau divided by sigma x minus sigma y. What is sigma 2 into tau? What is tau? 80. 80 divided by sigma x is 180. 180 minus 120. So this will give the theta. So tan theta, then divided by tan 2 theta divided by 2. If you put, you will get the theta value. So this is approximately some value around 35 degree. 35 degree. Now you find the sigma 1 and sigma 2. Sigma 1 comma 2 is equal to sigma x plus sigma y by 2 plus or minus root of sigma x minus sigma y by 2 the whole square plus tau. This is the equation. What is sigma x? What is the value of sigma x? 180. Since all are tensile, you put plus. Since all are tensile, you put plus 180 plus 120 divided by 2 plus or minus root of 180 minus 120 divided by 2 the whole square plus tau. Tau is equal to 80 square. You can find, if you put plus, you will get sigma 1. If you put minus, you will get sigma 2. You will get two values. You will get two values. Sigma 1 comma sigma 2. Two values you will get. Right? Now you find the maximum shear stress. Maximum shear stress. Tau max. What is the equation? There are two equations to find tau max. You can put sigma 1 minus sigma 2 by 2. This also you can put. Otherwise, we can use this equation also. Sigma x minus sigma y by 2 the whole square plus tau square. Substitute the values. Substitute the values. What is sigma x? 180 minus 120 divided by 2 the whole square root of plus tau square, that is 80 square. This will give the tau max. What is the, so now we know theta. Theta is equal to some 35 degree. That is, you will get some value. So sigma 1, the corresponding angle is theta. Sigma 2, the corresponding angle is theta plus 90. Tau max, the corresponding angle is at which angle is theta max is theta, tau is maximum when theta plus 45 degree, theta plus 45 degree. Now this can be represented graphically. So this is a vertical plane, this is a vertical plane. From the vertical plane you take 35 degree, you take 35 degree, you draw a line like this, you draw a line like this. What is this line? This is a line at which sigma 1 is maximum. Since sigma 1 is tensile, you put like this, you put like this. This is sigma 1, sigma 1. Now sigma 2, sigma 2 is perpendicular to sigma 1, that is like this. From vertical, what is the angle? This, what is this angle? This is theta plus 90. So if you put like this, this is theta, this is 90, theta plus 90. Now you, from here you take 45 degree and draw a line, draw a line. This is 45 degree, this is theta, this is theta. So theta plus 45. What is the direction of the shear stress? This is tau max. Always shear stress will be parallel to the plane. Here sigma 2, you have to put sigma 2. Sigma 2 is also tensile. You will get sigma 2 also tensile. So this is sigma 2. This is the way you have to represent the planes. Now you can see this problem. You can see the answer for this problem. Now you can. This is sigma 1. This is sigma 1. 180 plus 120 by 2 plus root of 180 minus 120 by 2 the whole square plus 80 square. This is 235. 235 tensile plus you will get. If you find the inclination, you put tan 2 theta, it will give angle some 35 degree. Then P2, sigma 2. Sigma 2 is Px, sigma x plus sigma y by 2 minus, you have to put minus. Here you have to sigma 1, you have to put plus. Here you have to put minus. If you put minus, you will get 65. This is also tensile. You will get a positive value. So it is also tensile. Similarly, you find the value of Q max. It is 85. It is coming 85. Now you can represent in a graphical representation. This is a way you have to represent it. This is vertical plane. From vertical plane, you take some 34.7 degree. 34.7 degrees. This is theta. You take this angle and draw this line. Here you have to mark the P1. Since P1 is tensile, it is away from the surface. If it is compressive, it is toward the surface you have to put. Then P2. P2 also tensile. It is 65. It is away from the surface. The inclination is theta plus 90. So you have to draw like this. The shear plane is theta plus 45. Then you have to draw like this. That is Q max. Okay. So this is a way you have to solve this problem. For solving this is an analytical method. This is an analytical method. The same problem also can be solved by graphical method. So this is graphical method. This is graphical method. In the graphical method, I will explain the same problem by graphical method. So here, what you need to do is, you draw a axis. You draw a axis arbitrarily. Arbitrarily, you draw the axis. Now you fix this is a O. This is a O. So sigma x is 180. When if you want to draw in a paper, then you have to take some scale. You have to convert the unit into centimeter, because we can mark in centimeter only. So here it is 180. According to the space available, you convert some scale. So here we can take 1 centimeter is equal to 20 Newton per millimeter square. I am taking 1 centimeter is equal to 20 Newton by millimeter square. Here 180 is given. So 180 divided by 20. So how much you have to take? 9 centimeters. 9 centimeter. So from here, you take 9 centimeter, you mark a point. Mark a point. This is known as A. So what is OA? OA is equal to 9 centimeter. So this represents the sigma x. Sigma x. Now take sigma y. Same scale. Same scale. OB is equal to 120 divided by 20. That is 6 centimeters. 6 centimeters. From O, you take 6 centimeters and mark B. You mark B. Right? Now, shear stress 80. So 80 divided by 20 is equal to 4 centimeter. 4 centimeter. From A, you draw a vertical line for 4 centimeter. You draw a vertical line for 4 centimeter. Similarly, from B, you draw a vertical line for 4 centimeter. You mark this as D. This is E. This is E. D. Now you join D and E. Now we join D and E. So this is a center point. This is C. This is C. Now you draw a circle. Now you draw a circle. C as a center. C as a center. C as a radius. C and CD both will be same. But here it is not proper. So take C as a center. C as a center. C as a radius. You draw a circle. You draw a circle. You will get a circle like this. You will get a circle like this. Now uh, this angle is 2 theta. This angle is 2 theta, and mark this as M. This point as M. This point as N. This point is N. Now you can measure the distance. Now you can measure the distance. Sigma, if you want sigma 1, you measure the distance OM. Measure the distance OM. This will give some value. This will give some value. Say this is 12 centimeter. This is OM. This is 12 centimeter. Then you have to convert it into, this is centimeter. You have to convert into Newton by millimeter square. For that, you have to multiply with 20 into 20. Some 240 Newton per millimeter square. This is not exact value. Approximately, I am explaining. Similarly, sigma 2. If you want to find the value of sigma 2, ON. You measure the distance, ON. Say this is 3.5 centimeter. Then you multiply with 20, that is approximately 70 Newton per millimeter square. Right? Now tau max. How to find the value of tau max? That is equal to radius of the circle. Radius of the circle, that is the distance C. Distance C. You measure the distance, say it is 4 centimeter into 20. Into 20, that is 80 Newton per millimeter square. Now position, angle. You measure the angle 2 theta divided by 2. So that is theta. What is the position of sigma 2? It is theta plus 90. Theta plus 90. What is the position of tau? It is theta plus 45. Always it is like that. Theta plus 90, theta plus 45. So we need to calculate magnitude. What is the magnitude? This is a magnitude. This is a position, angle. Similarly, sigma 2 magnitude and that position, theta plus 90. This is the magnitude of shear stress and this is a position. Finally, you have to draw graphically. How to draw? A vertical line. Then you take some 35 degree. You draw the what? Sigma 1. This is sigma 1. Then you draw perpendicular line. This is sigma 2. Then you take from here 45 degree and draw this line. This represents the tau. This represents the tau. Here you give the value, magnitude. So this is a way you have to represent graphically. Right? Now you can see this is a Mohr circle method. This is graphical method. This is Mohr circle method. You draw axis like that. You take O. OA is sigma 1. You take some suitable scale and mark the point OA. Then OB, that is sigma 2. Then vertical line. This is tau. AD also tau. BE also tau. AD also tau. Now you join E and D. This is center point. You take this as a center. C as a radius. You draw a circle. You draw a circle. Now you mark this angle. This is theta, 2 theta. This is 2 theta. If you want theta, you measure the angle divided by 2. That will give theta. And if you want sigma 1 OM, you measure the distance OM, multiply with some scale. Then for sigma 2, you measure the distance to O, n. Multiply with the scale. And shear stress, that is radius of the circle. Radius of the circle, that is C. And multiply with scale. Already we calculated the value of 2 theta. From that you find the value of theta. Theta plus 90 is sigma 2. Theta plus 45 is Q max, tau max. These are all the calculation, right? Finally, you would represent graphically like this. Finally, you would represent graphically like this, right? Like this. You got to represent like this. P1, sigma 1, sigma 2, tau, right? Now, same way. Other problems also same way. In this problem, there's a only difference is here sigma x is positive, sigma y is negative. Sigma y is negative and tau all are given. Now, the same way you can, but if it is compressive, you would put minus. That's all. The only difference is same way to find sigma 1, to find sigma 1, the equation is sigma x plus sigma y by 2 plus root of sigma x minus sigma y by 2 the whole square plus tau square, right? What is sigma x? Sigma x is 60. What is sigma y? Sigma y is minus 40. Minus 40. What is sigma x? 60. Here minus of minus plus. Here one minus is there. Already 40 is plus. So you have to put minus 40. That is minus of minus plus. Tau is equal to 10. You will get sigma 1. What is the position? Tan theta, tan 2 theta is equal to 2 tau divided by sigma x minus sigma y. Substitute the values. 2 into 10 divided by 60. Here one minus is there. Already it is minus. So minus of minus plus. That is 40. This will give 2 theta. From that you can find the value of theta. To find sigma 2, the same equation. Same equation, but instead of plus you have to put minus. You can get the value of sigma 2. What is the position? Theta plus 90. Then tau. Tau is equal to, there are two equations. You can use any one of the equation. Sigma 1 minus sigma 2 also you can use. If you substitute the values and find. And what is the value of theta? Theta plus 45 degree. Theta plus 45 degree. And this is a problem. Now this is a calculation. It's a calculation. You find sigma 1, sigma 2, then tan theta. Theta is coming 5.6 degree. In this equation, if you substitute, you will get two values. One is 5 degree, another is 95 degree. This 5 degree corresponds to sigma 1, this corresponds to sigma 2. But this alone is sufficient. You find the value of theta. If you put plus 90, that is sigma 2. If you put plus 45, that is tau. So then finally, you would represent like this. Here, tensile in the values are, see, and the sigma 1 is positive. It is 60.99. Sigma 2 is minus 40.99. What is the meaning? The stress is compressive stress. The stress is compressive stress. So, while marking the graphically, this is the plane at which sigma 1 is acting. This is tensile. So, draw like this. This is the value, magnitude. And 90 degree line you draw for this line. Here it is compressive. So, it is towards the surface. 40.99 and shear stress. It is 50. Mohr circle method. You draw the axis like that. Draw the axis. This is the point O. This is the point O. Sigma 1 is positive 60. You can take some scale. You can take 1 centimeter is equal to 10 Newton per millimeter square. Sorry, here you can take any scale you can take according to the space availability. Now here it is sigma 1 is equal to 60. So 60 by 10. 60 by 10 is equal to 6 centimeters. So from O, since it is tensile, you will take right side. This is the point A. This is the point A, right? Now sigma 2, it is 40. So 4 centimeters. 4 centimeters. Since it is compressive, you take left side, opposite direction. So this is what? B. This is a point B. Tau is 10. So always as we take, you take a downward direction, you take 1 centimeter, because we take 1 centimeter is equal to 10 Newton per millimeter square. This is 10 Newton per millimeter square. So 10 by 10, it is 1 centimeter. You take 1 centimeter downward direction. Here 1 centimeter upward direction. Upward direction. Now you join, this point is D. This point is D. This point is E. Now we join these 2 points. Now you join these 2 points. This is C. This is C. Now draw a circle. Now you draw a circle. C as a center, C as a radius. You draw this. You draw a circle like that. Now this is 2 theta. This is 2 theta. Now as usual, um, this is M. This point is M. And this point is N. Now OM. Distance OM is equal to sigma 1. Sigma 1 is equal to OM. You measure the distance, multiply with 10. It will give the value. Sigma 1. What is theta? 2 theta we know. You divide by 2, that will give the theta value. Right? Sigma 2, that is ON. Distance into 10. It will give the value. Position is theta plus 90 degree. Tau max. Tau max is radius of the circle. CE distance. CE distance. You put the distance into 10. Into 10. That will give the value. The position is theta plus 45 degree. Position is theta plus 45 degree. So now I hope